All right, class, in this video, this is going to be one of our last videos for Module 6, Systems of Equations, and we're going to work on writing and solving. So as we've been talking in class, there is actually a lot of practicality, if you will, to working with systems of equations, and so hopefully these handful of word problems will demonstrate that. I fully understand that these can be confusing. And so one of my really major points of advice anytime you're reading these word problems is just read them simply and slowly and take each sentence at a time. Often with these, you can take the first sentence, write down what you know, take the next sentence and write down what you know, and it will begin to fall in your lap. But you just got to give it some effort. I know that it's challenging, but just hang in there. So let's look at our first example. The sum of two numbers, so we have the sum of two numbers is 39. Their difference is 7. Now here's some important information. Math has its own language, and so let's start with sum. That is addition. The sum of two numbers, so we know how many numbers that we're dealing with here, is equals. So immediately I know that I have two numbers that are going to be added together to give me another number. Now we'll take this second sentence in just a moment, but let's start with our first sentence. In this case, we'll just do our first sentence. And it said we have two numbers. Why don't we just call them X and Y? We could call them A and B or L and M. You could call it anything you want. You could put symbols in there, but X and Y, generally in math, we're just going to use the X, Y, and Z terms. We know that it's a summation problem, right? So it's addition. So we're going to add these two numbers, and they equal 39. Now, when you see this equation right here, X plus Y equals 9, my hope is that you immediately see that we could write it like this. Right? We could write that in the form of y equals mx plus b, and we could graph it. So if I can get a second equation, because I have a different value here, right? I've got also another value. Let's change colors again. I have another 7, so I'm given another value. I see the word is, I know that's equals, and I know difference, well, that is subtraction. If I'm taking the difference between two numbers, I'm going to have to subtract them to make that happen. So what if we did the second sentence? Well, we want to use the exact same variables. I still have two numbers, and they're the same numbers. The sum of two numbers is 39. Their difference, so we're still talking about the same two numbers. Their difference then is 7. So difference, I have to make it a subtraction problem. And now my hope is that when you look at this, you see, okay, wow, I've got a system of linear equations, because this bottom equation could also be changed to be negative y is equal to negative x plus 7. Well, that's y equals x minus 7. I have two linear equations that I could graph. They have different slopes, so they're going to cross somewhere. There's going to be at least one solution to this equation. And I could graph it, use substitution. We've been working through those methods and come up to a solution. I could figure out what number is for x and what number is for y. But I could also use elimination, would be an easy one, right? Because I see my y values have opposite coefficients. One has a positive 1, and another has a negative 1. So when I add these two equations, these will cancel. X plus x is 2x. 39 plus 7 is 46. And so then I'm going to divide both sides by 2 and get x equals 23. Okay, so why don't we use substitution now and just say 23 plus y is equal to 39. I'm going to subtract 23 from both sides and get 16. So y is equal to 16. So my solution then, I have two numbers. My solution, if I were to do this graphically, they would intersect at 23 and 16. Now for a word problem, that doesn't necessarily give me what I'm looking for. The two numbers then, I have x equals 23 and y is equal to 16. Now think about it. If I add those two, well, I get 39. And that's what I saw up here. What happens if I subtract them? I'm going to get 7. So the two numbers are 23 and 16. I want to encourage you to pause the video and try this practice problem right here. All right, now that you've paused the video, we have the sum of two numbers, and there's my equal sign, so that's going to be is, right? So I have x plus y is equal to 14.5. Their difference is 5.5, so that's x minus y equals 5.5. I'm going to use the elimination method, so my y's will cancel. They have opposite coefficients, so that's 2x equals 20, or x equals 10. So the first number is 10. I'm going to plug that in for 10 plus y is equal to 14.5. Subtract 10 from both sides, and my y value is 14.5. Just a mild correction there. I heard myself say 14.5. Y is equal to 4.5 after you subtract the 10. All right, let's look at another example here. There we go. A company offers lessons for $15 per hour plus a $10 supply charge. Now, a moment ago I said take the first sentence and just deal with the first sentence. And so you don't have to write first sentence over here, but it might be helpful in your mind as you start to arrange these. So this company is offering some sort of a lesson for $15 per hour. So $15 per hour. And by now I hope you're recognizing that is a unit rate or a slope. Okay, so this would be like our m value. So if we started off with something that looked like this, we would replace the 15 with an m. So that would be y is equal to 15x plus b. And plus a $10 supply charge. So I went back to my equation, plus a $10 supply charge. Now that is what we would call a flat fee, and that is our initial value. So that's $10 here. So my first formula is y is equal to 15x plus 10. Well, what about our second sentence? Let's look at our second sentence. We have a different company offers lessons for $20 per hour with no additional charges. So $20 an hour, that's a unit rate. That's going to be y is equal to 20x. Now there's no additional charge. So that would be like a plus 0 y-intercept, which we don't show. So we'll just mark that off. So now I have two equations. I have two linear equations. So I have a system. Now ask yourself, what would be the simplest means of solving this system? My hope is you recognize that you have 20 equaling something, so I can use substitution and set this, take the 20x and replace y. What's my new equation look like? 20x is equal to 15x plus 10. I'm going to subtract 15x from both sides and get 5x equals 10, or x equals 2. X equals 2. Then it says the question was, for how many hours will they both cost the same? And now that question is, that's what I did here. I set them equal to one another. Here is company, we'll just call it company B, and this is company A. And each formula is how they derive their cost. So I set them equal to one another. And that's going to give me a number of when they have the same cost. So x equals 2. What if I were to sub this back in and say, okay, y is equal to 20 times 2. So y is going to be equal to 40. Now, we have to interpret this solution. So our solution is 2 in the x and 40 in the y. If I were to graph both of these, equations, they would intersect at the point located at 2 in the x and 40 in the y. But what does this mean? You've got to go back and ask yourself, what does x represent and what does y represent? X represents the number of hours. So this was $15 per hour. X is the number of hours. Y is going to be the total cost. All right, so this would be company A, company B. Y is going to, each of them are going to be their total costs. So for 2 hours, company B is going to cost you $40. But look what happens when I plug in 2 here. 2 times 15 is 30, plus 10 is 40. So for 2 hours, both companies cost $40. So your answer would be something like this. At 2 hours, both cost $40. And that would be the answer to that question. All right, let's scroll down and look at just one more. I would encourage you to pause the video and try to work through this one on your own. A total of 75 footballs, so 75 footballs and basketballs were donated to a school. So why don't we do this? X and Y. All right, and so we could start off with our first equation. X plus Y is equal to 75. Then there were 4 times as many basketballs as footballs. All right, now you've got to think about that last statement. There are 4 times as many basketballs as footballs. So what if we were to say Y is equal to X? Now that would mean they're the same amount of footballs and basketballs. So we would want to put a 4. This is the number of basketballs. This is the number of footballs. So if there are 4 times as many basketballs as footballs, then you have to really think through this. Then Y, the number of basketballs, has to be set equal to 4 times X, the number of footballs. Think about it. If there was just 1 football, there would be 4 basketballs. This would look like this. Y is equal to 4 times 1. So 1 football, 4 basketballs. And that's what they're saying there. You have to think through that. Now, let's take each of these equations. We have 2 equations here. The easiest way, substitution. X plus 4x is equal to 75. So that's 5x equals 75. X is going to go into that 15 times. All right, so just stop and think about that. What did I do? I substituted. I said, okay, so y equals 4x. I'm going to go into my system, and anywhere I see a y, I'm going to replace it with 4x. And that's what I did here. And then I just combined like terms, divided both sides by 5. So now I know that I have 15 footballs. Well, how many basketballs do I have? Y is equal to 4. I'm going to substitute 15 in for x. Y is equal to 60. So I have 60 basketballs. Again, I know these word problems can be very challenging. I would encourage you to walk back through this video. There's a couple of more problems in your book, several more practice problems. I encourage you to give those a shot.